Good evening and welcome to the Pinal Gem and Mineral Society meeting for January 20th, whatever date it is, whatever year it is, 2021. That's my roommate back there wandering about. He will be, no doubt, not wandering around anymore. He's gone to his room. Tish is in the waiting room here and signing in, so she will start in just a moment. I want to give you a couple of announcements. Our March show that we usually have in March will not be happening in March. We're going to postpone that probably until September. We're going to have a grand reopening that will include the show. We're aiming for Labor Day. We'll see how things are going and whether we can open up. We hope we will be able to. So that's new. Also, we will, let's see, what else we got here? Let's see, I got to answer a question here. Pardon me. Hopefully this will do it. Okay. They're just getting set up, and she's going to talk to us about aquifers tonight. What other news do I have? If you have not been following us, please do check out our website at penalgeologymuseum.org down there in the ticker. I want to also let you know that Tish is happy to answer your questions during her program. She will stop every few minutes and answer questions. So please do put your questions in the comments. We have one that I'll put up a little later, and we'll see what happens. Let me see. I'm trying to help her get some help with some tech problems here that we're having. She's having the same problems John Heilman had earlier on television. She's having an echo in her email, her ear. So trying to get that together. Let's see. What there's nothing much else here to. I don't know. Well, let me start to introduce Tishia. Tishia Stewart is a environmental educator. She is a National Geographic environmental educator, as well as running her own place, off-road adventures with Miss Tishia. And let me give you, I have a website for that. It's a Facebook page, but serves as her off-trail adventures, excuse me. That's down below there. You can check on her. And I think she's about ready to go. She hasn't got her sharing up and going, but hopefully she will do that. In just a moment. I'm speaking to her because it's the only way she can hear me. So at the moment, I can't hear her at all yet. Because I haven't let her be heard yet. All right, so excuse me, we're having some technical difficulties. So we're getting. We had a. I apologize for the technical problems this evening. Tishia did college work on all aquifers as well as or specializing in the Oglala Aquifer and its uses and conservation. She will be hopefully getting up here and just okay. Yeah, we're okay, Tish. Just if you haven't yet, consider volunteering for the museum. Ray has done, the director, Grant, has done a marvelous job this summer. I understand. I haven't been over there yet. Refurbishing the museum with some volunteers. It's another reason we want to do a grand reopening this fall. He's been working this winter and will continue to do that and has some new exhibits, some updated exhibits, and lots of new displays. So I'm looking forward to seeing those myself. I've only seen a few pictures, and hopefully I will get over there soon, and hopefully we will be able to show that off this fall. We're aiming for, if I didn't say it before, we're aiming for Labor Day weekend for our show and grand reopening. Again, that will depend on COVID and other things, but we're hoping to do that. Tish, I'm going to put you on screen, and then maybe we can talk and see if we can talk you through this. Okay.
Okay. We're just trying to.
That's Tish, everybody.
Yeah. So are you able to hear me, Bob?
Yes.
Okay. So my son brought me over a nice screen in which to do a screen share, like to split the screen. And so I'm just trying to get that up and going here for you. And it's not wanting to work for some reason. Hold on. I might just have to put it back over here and not see y'all. So let me move you down. Doggone it. Okay. All right. So just like last night, you can still hear me, right?
Yep.
Okay. So I've got it on. I've got the PowerPoint open, and then I need to go into slideshow mode.
Mm-hmm.
Okay.
The slideshow play in window.
The play slideshow in window?
Yes.
Okay. All right. And then
back in the browser, go to share screen and share application.
Okay. And share screen. Oh, it's giving me. All right. Hold on. Okay. It's not showing the application window. That might help.
There you go.
That might help. Where is it? Can y'all see it?
Nope.
No. Are we crazy or what? Okay. So what am I doing here? I went up here. It's in there. I did the application window.
And you then clicked on the PowerPoint window?
Yeah, I've got all of that going here. Hold on. We'll do another share screen. Share screen. See, it's application window. And maybe I'm missing something here.
Well,
Give me a second, guys. This is all brand new to me for this particular. Okay, is it this one? Can you see that one?
Nope.
No? Okay. I am doing something wrong here.
Okay. When you share screen, and you click on the share application window. Do you see PowerPoint?
Okay, hold on a second. So I'm going up here to share. No. Play slideshow in window or play slideshow?
Well, that's in PowerPoint. That's not in your browser.
Okay.
So you want to play slideshow in window.
Right. Okay.
Okay, and
All
then
right.
switch
So,
to your browser. So you see us,
all
you
right.
and I.
Okay. Now I can see you guys,
All
but
right. All right. And then at the bottom, there should be share screen.
yeah, I got that.
Okay. And you
then
press
share
on share
screen,
screen, and those have the application window
application window,
and your
and it's
PowerPoint
showing,
slideshow.
and there. Okay. Let's see. Is it
It's not
coming?
coming through.
Well, what in the world? You guys. All right. Let me, how many of these do I have here? Okay. So go back. You know, it worked last night. How come it's not working now? And share screen and share window, application window.
And do you see the PowerPoint window there?
I see where it says, oh, you know what? Hold on a second. Maybe this is why. Let me just close out of there real quick. And do. Okay.
Technical issues, folks, happen every once in a while, and we're experiencing some technical issues.
They always
That's
happen with
okay.
me. Okay, give it a moment. Come on.
Not coming through.
Well, I had to close it out and reopen
Oh,
it.
okay.
And with it being a kind of a large file here. Okay, so, all right, let's try it again. Okay, so play slideshow in window. And then I want to find you guys where I can see you. And then share screen, application window. You know what? It's not wanting to show. Follow these steps. Ugh. Now I don't want to do that. It's got something coming up here. My son went and did something with my computer today. Is it coming up at all?
Nope.
Well, pooh, you guys. Well, this is going to be disappointing if this doesn't work out. Still nothing?
Nothing?
Am I doing something wrong? I wasn't supposed to do anything on my end as far as
No, just the share screen. You have the PowerPoint open.
Yeah, I did all that.
And you share, and from your browser window, you share screen.
Yeah, I did
Share
all that.
application, and PowerPoint should show. And then you click on PowerPoint.
Yeah, it's showing. It's not showing anything. It's not showing. Hold on. Cancel. It's not showing the PowerPoint, you know, on that application window.
Mm-hmm.
It's just blank is all it is.
Okay, that means it's not showing it's not showing you don't have an option to share the desktop or.
Hold on. We'll try it again. And here's you guys, share screen. And then do I need to?
You should have a chance to show your desktop or your browser window.
That's what I'm
At
looking at.
least.
It shows the PowerPoint, but it's just not showing the picture like it did.
Well, click on it and see what happens.
I did, yeah.
Okay, then is your PowerPoint not?
Oh boy, nothing's changed. since yesterday, so I don't know what the...
Is your PowerPoint actually up and running?
Uh-huh. Yep, it sure is. Otherwise, I'm going to just talk to y'all, but that's not going to be any fun.
Well, talk to us. We're quarter hours into it, so
Okay.
talk to
Well,
us. And
so as y'all
if you
heard,
want, you can send me the slides, and I can intersperse them with the talk.
okay,
We can do that later.
yeah, let's do that. So let me go back to my email here. Come on. There it is. Okay. Attach. And then
We'll do that. Okay.
And come on. And I've been here for 2 hours. Okay. It's saying that, okay. It's saying that I got to share it with you through Google Drive.
That's okay. We'll do it later, and I'll edit it in after it's up. So
Okay,
just give your talk the best you can.
So how do I do that
slides.
through the Google Drive?
We'll talk about that later. Let's
Okay.
go on with the program for now.
All right. So anyway, my name is Tish, and as Bob was sharing with you a little bit ago, I had done some research several years ago about the Oglala Aquifer and some of the environmental impacts that are occurring there and have been occurring since the late 1800s. And as we all know, water is one of those precious commodities that without it, there would basically be no life. And so anyway, with the Oglala Aquifer, one of the things that I wanted to show was how it was formed. And in my neck of the woods where I'm from, in eastern New Mexico, we live on top of what's called the Llano Estacado. And it's basically just this huge plateau, one of the largest in the world. And geologically speaking, the Llano Estacado was formed by the early uplift of the Rocky Mountains. And if you're familiar with the Rocky Mountains and where they're located, we do have the tail end of them up in the northern state or the northern part of New Mexico. And what I find pretty interesting, I know that when I was working on my Texas Master Naturalist certification, was we had a couple of geologists with us, and they just grabbed a handful of all of this rock and gravel and sand, and they were showing you a little bit about the origin and pulling out some books and whatnot and showing you the origin of where all of this rock and gravel and sand came from. And I thought, holy cow, that's pretty nuts, to think that the Llano was formed by the early uplift of the Rocky Mountains. And when I began to do my own investigations, my daughter and I, we took a drive out to the edge of the Llano going up towards Tucumcari. And we got out, we walked along the escarpment, and lo and behold, we were finding shark's teeth. We were finding shells and other clues that told us that there was an inland sea. And so when you start putting those pieces together, what you find out is that during the uplift of the Rocky Mountains, you have this inland sea that's bringing in, if you will, all of the sediments, all of the rocks and the gravel and the sand and the silt, and it's just kind of piling it up in any old which way. And as those ocean waters began to recede, now you've got some ancient rivers and some streams that are starting to carve out that land, if you will. And I'm sure that many of you have taken a plane ride over like the Colorado Plateau, and you probably have seen the Painted Desert and the Grand Canyon from way up high. And when you're looking out the window, you get a real sense of smallness, if you will. You feel real itty bitty. And that is something that a lot of people don't really get to experience. And if you're not really sure what you're looking at, well, then you just fly right on over it until you get to your destination. But you can see, for example, the Colorado River and how it carved out what we see today as the Grand Canyon. But if we backpedal just a little bit and we're to change course and head out towards Dallas, Texas, if you will, then you end up flying over my neck of the woods being, of course, New Mexico, and then right over the Llano Estacado itself. And so getting back to the Rocky Mountain uplift and whatnot, when you start putting your imagination together, it really starts to paint this historical and geological picture of what was going on. And so when you take a look at the Llano, it resembles a lot in terms of the features that you would find out on the Colorado Plateau. All of the ancient rivers that used to flow across it. And as a matter of fact, one of the things that really helped to shape the Llano that we see it as today are those rivers and those streams. And so part of the PowerPoint was that I had taken some pictures of the escarpment from far away as well as up close, so that you can get an idea of what it would have been like to have flown over this wonderful piece of geology, if you will, this land, as well as if you were in a car and you were driving up to it. And so when we think of this being carved out, one of the really cool things is that we know that thousands and thousands of years ago, the last ice age. And when we think of those receding glaciers and the snow melt and whatnot, what happens to that snow? What happens to those glaciers? Do they stay in their original form, or do they, begin to melt, evaporate? What goes on? And so what begins to happen is that as those glaciers are beginning to recede and as temperatures are beginning to rise, we have all of those rivers and streams that are filling up. We're getting a cutting and the eroding away of all of the strata that has piled up on top of each other that forms the Llano and the surrounding areas. But also, too, what's pretty cool is that the Oglala Aquifer is quite large. As a matter of fact, it is the largest aquifer in North America. And I don't know how many of y'all do that. I didn't know it. I didn't even know what the Oglala Aquifer was. I thought it was bottled water that my mom drank from. And what we find out is very much like that bottled water that holds that water inside. The way that the land is shaped and the way, especially the Llano Estacado, the way that it's all shaped, and the way that the sand and the gravel and the rocks, it actually encases the Oglala water that's in there. And what I find pretty cool is when we connect the dots and we go back to the early or the last ice age, hydrologists and geologists actually consider the water, the groundwater that's encased in the Oglala formation, if you will, as fossil water. So once again, here in North America, we have some pretty unique features. And to think that we have the largest aquifer that sits right in the middle of America, that extends across 8 states or underlies 8 states, all the way from Wyoming to South Dakota, down through Nebraska and into West Texas and Colorado and New Mexico and a couple of other states. But anyway, it's over 175,000 square miles. Now, I don't know about you, but 175,000 square miles is very, very large. And when you take a look at a map, and you look at those states that I've mentioned, and you kind of see the zigzag pattern that forms where that Oglala Aquifer really sits, you begin to have this appreciation of water. And so going into, not only the ancestral uplifting of the Rocky Mountains, and then going into that last ice age until the present day, formation or the present day features of what we see when we are traversing about the land, whether it's by air or by ground. What we know is that that whole landscape is relatively flat. You have the northern plains, and then we have the southern high plains. And the southern high plains, being where I'm from, it's pretty semi-arid. The climate is semi-arid. The further west or the further east you go, the precipitation rates do increase. And we know that the further north you go, the precipitation rates do increase as well. And so when you take a look at the map, and I'm going to, and as I would tell my students, I'm going to challenge you to look this up.
I've got a map. I'm gonna. Oops, excuse me. Here, I got a map on the screen. It's not perfect, but it's of the aquifer.
Yeah, there you go. There you go. So as you can see there, you can see how it just kind of zigzags. And you know, I mountain bike, and one of the things I was chuckling over the other day was the fact that when I look at that dark blue area that's on that map there, it kind of looks like the trail that I ride just right up the road. So anyway, there's always these connections that just kind of boggles my mind just a little bit, because it can be kind of fun and silly every now and then. But when you take a look at that and you look at the northern part of or not the Llano, but the Oglala Aquifer, and remember, that is where most of the precipitation occurs. And so that's where you're going to get the deepest parts, the thickest part of the groundwater itself. And so when we talk about like water conservation education, whether it's through the University of Arizona, and that's where I first started working when I moved out here from New Mexico, and even with the Oglala Commons out in West Texas area, and it actually extends even further than that. But one of the things that I love to show kids and adults is a great visualization of how water moves through the aquifer. You know, how does it move through the sand, the gravel, the rocks, the silt, the clay? What about caliche? Oh my gosh, out here in the desert, I don't know how many of y'all have ever tried to dig in your backyard, or maybe you went for a hike and you notice that, you know what, that ground is pretty hard over there. It looks like concrete, you know, and you realize that it's not really concrete, but it's caliche. And it's just kind of this impermeable layer of rock. And I believe is it an evaporate? I know that, you know, all this weird stuff happens, you know, whenever you are learning how to identify rocks and minerals. But anyway, needless to say, the Oglala Aquifer is encased, it's encapsulated by this caliche, and it's very hard, very, very hard. And I was sharing with a friend of mine who happens to be here tonight about how here, whenever I was a park ranger, I would take the Canadians and we would go up into a couple of the washes here at Santan Mountain Regional Park. And I would have them use their imagination just a little bit about the power of water. Just imagine, if you will, this water that we use for cooking and brushing our teeth and flushing our toilets and drinking. Imagine it coming down, you know, through these washes and scouring out these corners here. And you could see where these huge boulders of caliche just piled up on top of each other. And it's basically impermeable. And so when we think of that impermeable layer and then we apply it towards that Oglala Aquifer, then you get a sense of just like that bottled water and how that keeps it all together. Now then, what's pretty interesting is, and I'll get to that experiment, is when we want to share with our students or our audience, well, how does that water move through the different kinds of strata, or how does it move through sand or clay or whatever? And one of the things I love to share is, if you know, you can go and you can get these clear tubes, and perhaps some of you have already done this before, and you can fill a 2-liter bottle or clear tubes with different kinds of, you know, one with sand, the other one with gravel, the other one with a mixture of the two, whatever. And I like to have kids hold stopwatches and kind of guess, you know, which one do you suppose water is going to move the fastest or the quickest through? or the slowest? And they all like to guess and pretend and whatnot. And so we go ahead and we pour that water into those tubes, and they start those stopwatches. And then the folks that are with the sand, boy, they're just standing there all day long waiting. Whereas those with the gravel, oh yeah, they're watching it go through. Okay. And then those with the rocks, boy, they're really watching it go through. And so what that allows them to see is, how does water move through those pore spaces that we find in between all those little grains of sand or pieces of gravel or those big chunks of rock. And that gives them a really good idea of just how fast or how slow water moves through an aquifer. And so, as I mentioned earlier, the Oglala extending all the way up into Nebraska and Wyoming and coming down through West Texas and eastern New Mexico. Can you imagine how slow that water must move from the northern states down to the southern states? And by doing a little bit of math, you could come pretty close with an estimate of how many years it's going to take for that water to move just a few inches. And again, that depends on the strata, the gravel, the sand, what kind of substrate is down deep in there. And a couple of the projects that I'd been involved in, one of them was with the Texas Tech University and their hydrology department. And what was neat was that we would go around throughout West Texas and eastern New Mexico, and we would check some of the monitoring wells. And those monitoring wells, and I bet you anything, there's many of you out there that already know what they are. But those monitoring wells, just by what the name implies, is that you go over there, you take the lid off, and you pull on this rope or the chain. And at some point, you get to this tube. And inside that tube, if you will, and if you just kind of think of it as how you would test for water quality or your pool water, and it gives you like this different color code, if you will, and it tells you, what kind of chemicals or what's in that water. And not only that, but it also lets you know how deep is that water. So, we have confined aquifers and we have unconfined aquifers, and then we have saturated and unsaturated zones. And it's interesting to think that not only in New Mexico and West Texas, but throughout where we find farmland, is that you're going to have fluctuations in the amount of water that is available to farmers. And right now, what we're seeing is the more you dip those straws, if you will, into the aquifer, you know what? That's going to affect your neighbor as far as the kind of water that they're going to get out of there, as well as how many gallons per minute that they're going to get out of there. And here's something pretty interesting is here in Arizona, and Bob and I, we were talking about this last night, is not too far from where I'm at right now. You can find fissures. Some of those fissures are brand new. And here at Santan Mountain Regional Park, where my friend just retired from, he had noticed that there's a big fissure that just opened up over there. And why is that happening? Where are we getting our water from? Are we getting it from the Colorado River? Are we getting it through our canyon lakes? Or are we, withdrawing it from the aquifer? And when we think about where the aquifer is, it doesn't just sit in a cup of water or in a bowl. We have to dip our straws down in there in order to pump it out and to give us water. Well, because it's underground or below ground, it's not what many people think. And a part of what I had tonight was when you ask people, not only where does your water come from, but what is an aquifer? And I don't know how many of you have gotten this answer. Oh, it's an underwater river. Oh, it's an underwater reservoir. It's an underwater lake. Well, kind of, sort of, but not really. We know that those things exist, but the aquifer itself is all within that sand and gravel and clay and whatever else that just so happens to be, below our feet. And so if you think of that water balloon, okay, you've blown up a water balloon, you put water in it and you pop it. What happens to that balloon? Does it hold its shape? Absolutely not. It pops, but we can think of it as collapsing, and therefore we get sinkholes, we get subsidence, we get all kinds of crazy things that are going on. And so what we're finding here in Arizona is the same kind of things that we're finding out in eastern New Mexico and the West Texas area and all the way up through where farming, and I'm not picking on agriculture by no means, but in this time we're concerned about global climate change, food production, growing cities. Where's that water going to come from? Well, that's why when we start having new communities popping up, the housing developers need to show a 100-year plan of where they're going to get that water. And so the history on the Llano Estacado, oh my goodness, I don't know if y'all have been there, but the land is so flat. I tell my friends, oh yeah, I went trail riding back home, and it took me 3 days to gain 63 feet in elevation. Well, why is that? Well, it's because the land is so flat that really you could watch your dog run away for 2 weeks. It is that flat. But during the late 1800s, when people were coming across the plain states, they were bringing their families, they were bringing their sheep, their goats, their dogs, everything. Okay, they were running the plains Indians off the land just as quickly as they could. They were getting the bison off the land just as quickly as they could so that they could get the cattle out there and the corn and everything else. Well, here they go. They start planting windmills all throughout the Llano and all the way up to where, we're able to find water. And they started pumping that water out in which to what? Water their plants, their crops. Well, Tish, why didn't they just go to a lake or river, or stream? Well, guess what? There is no surface water there. It's basically a desert. And so when they started putting in those windmills, they started popping up all over the place like freckles on somebody's face who spent too much time in the sun, And then, guess what happened? In the 30s, if y'all remember the Great Depression, we had the Dust Bowl. All that topsoil blew off as far as New York City and all the way out into the Atlantic Ocean. And how many years did that last? Several years. Well, by World War II, gasoline engines was starting to become the big thing. And then following World War II, farmers started to figure out that, hey, you know what, if we take this gasoline powered generator and we put it over here to our windmill, if you will, we could pump out a lot of water. Well, yep. And guess what? Now you look at how much water is being pumped out by the center pivot irrigation. It can be anywhere between 500 to 2,000 gallons of water per minute. And we're talking coming out of a pipe about 12 inches in diameter. Now, I don't know about you, but that certainly is a lot of water. Okay. All right. So I'm going to go ahead and I'm going to stop here for now. And if y'all have any questions, you're more than welcome to ask. I like your questions. And if I don't know, I'll just send it all over to Bob.
Tish, do you have an idea of the recharge rate of an just a generalized, does it take a year? Does it take a century?
Oh, I love that question. I love it. Yes. So I will send Bob the PowerPoint that I did because I included a few maps that show you saturation levels and how much they've dropped between just basically 1997 up until about 2012. I know that Texas Tech was still working on data and providing some new info. But yes, we are withdrawing more water from the aquifer than what is able to be recharged. Okay. And so estimates put it that in the West Texas and Eastern New Mexico alone, that maybe 1 inch of water per year is what is being able to percolate back down into the aquifer. And so just within the last 30 years, depending on where you're at, okay, now remember those northern states, the aquifer is a lot shallower and closer to the surface than what it is down in West Texas, eastern New Mexico, parts of Colorado, and Kansas. And some of those people are having to drill new wells. As a matter of fact, a friend of mine who's a cattle rancher out in Texas, he had to drill for new wells because he's not getting any more water. And that water, getting back to answering that question, the levels of the that saturation level where you're going to find water has dropped over 90 feet. 90 feet. So is that the average? Pretty much, yes. But again, it depends on what region you are in. So the further north you go, you're going to hit water a lot quicker and at a shallower level than what you will getting further south. Okay. And so back in the 1980s, when I was just a little kid, and I tell my kids, oh, that's when the dinosaurs were here. There was talk of bringing in water out of a lake that's north of Tucumcari called Ute Lake. And they were planning on pumping that water on up to the communities because they were finding out that, you know what, we're running out of water a lot faster than what we're realizing. And what they discovered is that, well, if there's no more water, guess what? You're going to have to ration water, or you're going to have to quit farming, or, it's one of those things where you either survive or you move or you die. And so a lot of farmers decided, you know what, we're moving, we're going out to Texas, or we're going up to the San Joaquin Valley of California. And it almost seems like the moment that farmers either change their crops or they quit farming altogether, guess what they noticed, and rather quickly, was that water levels began to come back up pretty quickly, and not in all areas. So again, it just kind of goes back to the geology of that particular region. And it's pretty interesting because, like I said earlier, with the monitoring wells, a friend of mine who's a wildlife biologist out at Muleshoe National Wildlife Refuge, we would go around the refuge and we would check, because surrounding the refuge is agriculture, dairy, feedlots, all the corn and sorghum, everything. And not even 10 years ago, when there was a really bad drought, farmers were changing their crops, going from water-loving crops such as corn to cotton. And within 3 years, we noticed that the saline lakes that are out there on the refuge started to fill up. We were finding these little seeps and springs. And then we were doing some salt cedar abatement, removing salt cedar. And we were noticing within a couple of months that what started out as a little old puddle is now a 3-acre wetland. So, water has a real interesting way of finding a way to reveal itself, but yet it's sneaky enough to be avoided when it's being slurped out faster than the recharge rate itself. Okay, so I'll stop again and I'll get into how is the aquifer recharged? What's being done about that, and then just kind of hit up on some environmental concerns as well as the plants, and then we'll be done. Okay, so does anyone have any questions?
I'm not seeing any other questions at the moment.
Okay, well, that means everybody's a smarty pants. That means everybody is.
No, you're doing a really good question. There was a question earlier, actually, and I answered it on YouTube, but someone thought he was being smart and asked if the groundwater was, oh, hello, I do have a question. He thought Ted was being smart and asked if our groundwater was liberal or conservative. And my response was, I think we should be conservative with our liberal application of groundwater.
Yeah, I totally agree. Yeah, you don't want to, it's like these kids, you ask them, where does water come from? They'll tell you the faucet. Mm-hmm. Are we ever going to run out? No, as long as mom pays the bill, we'll never run out. Not realizing, that water isn't always available. I mean, look at it. I mean, where's our water locked up at? In the oceans, in glaciers. I mean, and of the 100% of water that is available, what do we get? Like 0.2% or something like that, just a little smidge. And so we really have to be careful with water. The water that I show my kids that I'm drinking, not my personal kids, but my students, I say, hey, you know what? The dinosaurs could have drank that. Because when we think about the water cycle, yeah, it continues to cycle around, but where is it locked up at? And have we figured out a way to desalinate the water from the oceans in a very cheap or inexpensive way to where we can afford that? The technology.
And then we still have to pipe it to Arizona or New
Yeah,
England.
we do. Or we're just all going to have to move.
Yeah.
So, the technology is there. And, and when I'm teaching STEM classes, that's some of the things that I challenge my kids to try to come up with solutions. What are their ideas? And so when we think about water, we can find it just about anywhere. But we live here in the Sonoran Desert. And as I was sharing with Bob last night, what are we doing bringing in grass? Why are we bringing in plants from Florida and Nebraska? We should be native-scaping instead, using plants that are local, things that are used to the little bit of rainfall that we do get. So where does our water come from? And then how do we recharge that water? What's interesting is Kansas has probably, and this, here you go, Ted, Kansas has the most liberal rules and regulations as far as how water is used.
Okay, that's good. Ted has the follow-on question. Does farming or community development use more water in general?
Oh, wonderful. And this is why I wish the PowerPoint was here, because 96%, okay, now you can check the records because I can cite my sources, okay, but 96%, according to Texas Tech, the hydrology department, okay, 96% of water that's being used right now is agriculture. 2% of that is municipal water. The water that's being used for your homes and to water your grass and to cook your food and brush your teeth, flush toilets, do all of that, 2%. 96% is agriculture. And when you think about where most of our farming occurs, it's where I'm from is like the bread belt, if you will, And when you look at center pivot irrigation, each one of those crop circles, and I'm not talking about the one where the mothership has come down and rearranged your corn crops. But when we look at those crop circles in of themselves are 160 acres, 160 acres. And when that center pivot is running, it runs nonstop, 24/7. 24/7. And now let's do the math. If you have 10 of these crop circles and you're running your center pivot irrigation sprinkler to go around, water that corn, and 500 to 2,000 gallons of water is being pumped out per minute. Wow. 24.
How much does anybody know how much of that evaporates, turns into crop, as opposed to some of it surely goes down and is not lost. It goes back into the aquifer. I'm sure it's not much, but do you know how much?
It's not very much. It really isn't. And here's the reason why. And compared to what irrigation was maybe even 30, 40, 50 years ago, compared to what it has become so efficient. Okay, so efficient at irrigating crops at a much closer level. It's more ground level than what it is. Years ago, whenever we would drive down the highway, the water would be spraying all over the place on top of the crops, and most of it would evaporate before it ever reached the ground. Now those lines have to go all the way down and almost touch the ground in order to get closer to the ground, closer to the roots. Less water is used. And so the amount of moisture, or the amount of water that is allowed to percolate back down into the aquifer, is less than what it is when you get a good rain. And so that kind of leads into the next area of where, and we could talk about the recharge, but just, it's just interesting. I'm just trying to keep my mind is going over here and then I'm thinking this way. But, irrigation has become so efficient, as I said. And also too with, a friend of mine, Robert, who works with New Mexico State University, he does these huge dairy consortiums every year. When I was doing my research on the environmental impacts on the Oglala Aquifer, I had gone to probably just about every dairy farm that was in West Texas and Eastern New Mexico and up into Colorado and Kansas. And that was over 100 of them. And you're probably going, oh my God, how the heck did you have so much time? Because I had a lot of time. And I had 2 years to do this. And I also went to small family-owned farms, and not just dairy and cattle, but farms in general, where they were growing, crops and of different kinds. And what they were doing differently, and this is kind of goes into the back end of the presentation tonight, is what are some of the plans that are going into making water availability more sustainable? And when you look at soil quality, now out here in the desert, you'll notice that when it rains or maybe it sprinkles, you get this this white crystalline structure or powdery substance. That's salt. That is salt that worked its way back up to the surface by capillary action. And so farmers out here really have to water their crops with a lot of water in order to push that salt down past the root systems of those plants. Well, there in New Mexico and West Texas, it's kind of the same thing in certain areas, but we have a lot of clay-y kind of soil as well. But anyhow, the difference between like large scale farming versus small scale farming, when you compare organic farming versus, the big commercialized stuff, one of the things that small farmers are doing is rotational grazing. That's where they allow their cattle to graze over here for a short period of time, and then they rotate them around. It's kind of like looking at your pumpkin pie and you're going to eat this slice and this one and this one and that one. It's kind of that same concept. And so what does it do? It allows that soil and that vegetation to rest. Let the soil rest, but then, and there's a certain percentage, you don't want your cattle to eat more than 70% of the vegetation. Why is that? Because you want to force that vegetation to grow strong roots. When you have stronger roots, that taproot goes way, way down deep to where that water is, and you're going to find that you don't have to use as much water. And so also too, what they're doing is no-till farming. I don't know if Jim's still here, but he's from Illinois and he's from, farming country out there as well. And one of the things that they're practicing now, and there's a lot of really good data that supports it, is no-till farming. That means when you've gone out and you've harvested your corn, you leave those stalks standing. Why? Well, because we know that the breakdown of that plant material is going to add to the nutrition, if you will, of the soil itself. But then also too, as it breaks down, it begins to, it's that organic matter that really is healthy for the soil. And so what they're finding out is that allowing that to happen, that moisture, it allows for the soil to really hold on to that moisture a lot better than if you went out and tilled your ground and just let it. It's like the difference between leaving a wet sponge out on the sidewalk versus having a wet sponge in a Ziploc bag. Which one's going to dry out? Well, not the one in the Ziploc bag. So if you think of the no-till soil, the organic soil, as being very loamy, it's going to retain that moisture a lot better than that soil over here. So that's another strategy that they're using and finding that is actually working to reduce the amount of water that they're using for crops. So just real quickly, I wanted to just kind of catch up on, let's see, I mentioned no-till farming, cover crops, rotational grazing. there's a lot of conservation education that's going on out there that I was a part of before I came out here that is working miracles. I tell you, you get to the kids and the kids get to the parents. And next thing you know, you have parents coming in who are these big farmers and ranchers, and they're getting involved with the NRCS, the Natural Resources Conservation Service, and they're putting their land to rest. And part of that ties into how is the aquifer recharged? Up in the Dakotas, and I'm sure that y'all are familiar, especially Nebraska, the prairie potholes. And then when we bring that smaller version down into West Texas, Colorado, and those other states, we have what's called playa lakes. Playa lakes are these ephemeral wetlands. And we won't get into the wildlife side of it, but the water part of it is that they are watersheds. Now, remember, the flat country does not have lakes, rivers, and streams, but they have playa lakes, and they're basically a depression. So if you were to stick your bowl on the table and you were to fill it up with water, that would basically be a good representation of a playa. Those playas are clay lined. And if you know anything about clay, you'll know that when that clay dries, if these huge fissures form, okay, these huge fissures form. Now then, let's bring in the water. Well, that water is going to run down. Okay, that storm water is going to run down in between those cracks of the clay, and guess where that water is going to go? It's going to start percolating down until eventually it reaches the aquifer. And so on the Llano, between West Texas and Eastern New Mexico, there is an estimated between 45,000 to 60,000 of these playa lakes. And they believe, and I don't mean just they, like anybody, but hydrologists and even the archaeologists and NRCS and a bunch of other people who study playa lakes know. And what they figured is that about 85% of Oglala recharge occurs there in those ephemeral, in those playa lakes. And so it's pretty interesting because we can get into the seismology, we can get into a lot of other things that are associated with that, but it's pretty amazing. And I'll just kind of finish up and we'll just wrap things up with any final questions and thoughts. But one of the things too that we did with NRCS was, and Texas Tech hydrologists, is we went out and we did some bore sampling. And it's basically, I just use a straw. We just stuck a straw down into the soil and we bored out this long, oh my gosh, it's taller than the ceiling in this classroom. And you can see the clay level or the clay layers. You can see the loamy soil. You can see all of the different things that make up just what is underneath the playa. And that gives you a really good glimpse of how water percolates through those playas, as well as those hard data, those numbers that y'all like to play around with, how many inches and what percent. And anyway, it's those playas. They're finally being recognized by the EPA. They used to not be protected under the Navigable Waters Act, but now I think June of last year, they finally recognized playas to be truly something that needs to be protected and preserved. And so a lot of farmers who own massive tracts of land, they are now realizing that there is benefit to preserving and protecting these playa lakes aside from their farming, because they know that for them to survive, remember, water is a limiting resource, but for them to survive, they've got to protect that source. And where is it at? Right there in the playa, right there. So the geology is pretty magnificent. I think it's wonderful. It's really changed my opinion of how I view my neck of the woods when I go home. And there's so much history and just some really wonderful things that are happening. But as mentioned before, we're really going to have to take some measures in how are we going to make this sustainable. We know the population of the planet is growing. We know communities are growing. More and more people are going to rely on food. And I know a lot of people will snub their nose at genetically modified food stuff. But, we got to figure out how are we going to protect what is ours while feeding the world. Okay, so I'm going to go ahead. I'm going to leave it there. Are there any questions up until this point, or maybe something might have sparked your interest and you're kind of curious and kind of takes you in a different direction? And if so, go ahead and share that.
Tom, let's see. Tom says that he grew up in Kansas, and it's amazing how he can see the older wells that have dried up, but the land around it has dropped by many feet from where it started.
Yeah, there's a couple of pictures. I believe that they were taken in like the 1940s, and it was pretty remarkable. There's this telephone pole, and right next to the telephone pole is this old farm road, and they marked where the ground level used to be. And once center pivot irrigation became, the normal way of how we, how we water our crops and to really multiply our crop fields in terms of production and size, the amount of subsidence that occurred, I mean, it was like over 20 feet, just in how that ground had, sunk as a result of the depletion of the aquifer. And like I mentioned earlier, a friend of mine in cattle ranching, he had to go and drill for new wells. And he was having a hard time, but his neighbor across the street or across the road, a couple of miles down the road, they were fine. So it's just kind of a hit and miss.
I know in the last few years in California, they've had droughts and water problems, and the Central Valley has dropped something like 6 feet in areas just in the last 2 years.
Yeah.
3 years.
Yeah. A lot of the farmers have been coming in out of the San Joaquin Valley, not just because of tighter controls, but there's not much water. And so they've been heading out towards, West Texas, New Mexico, Kansas, and Colorado. And so more and more, we're seeing more and more farming and just kind of backpedaling just a little bit with the environmental stuff. Here's something that I found out recently is that in the 1950s, we have Cannon Air Force Base. Now, this isn't the only location where this happened. I know Edwards Air Force Base has had the same problems, and that was they used a fire retardant, and it was called PFAS. And I'm going to try to say this word, and I know I'll probably butcher it, but a couple of the dairies there just outside of town between Clovis and Portales, where Cannon Air Force Base is at, a couple of the dairies had to go out of business because they had found out that this particular chemical, polyfluoroalkyl substances, was way beyond the allowable amount that the EPA and the New Mexico Environmental Department, parts per million. It was so elevated that they had to go and dump millions and millions of gallons of milk and slaughter all of their dairy cattle. And some of these farms had in excess of 2,600 head of cattle. So imagine being a family-owned business and having to see that happen, and you had to uproot everything, because once that water is contaminated, that's it. You're done. You're out of business. And so just now, Cannon Air Force Base is having to cough up several $1 million to clean that up. And I don't know how they're going to do it. I don't know how. And so as I was sharing with Bob last night, there's a couple of studies that are going on, botanically speaking, with California bulrush. California bulrush is one of those few plants that they're finding out that might be able to metabolize, in other words, break apart those chemicals so that it's not harmful to humans for consumption.
Bulrushes are excellent water cleaners.
Yeah. So, I tried to touch up on everything that was in the PowerPoint, and I hope that I was able to create kind of a good visual. And Bob, thank you so much for your patience and pulling up a map and being of help and all that. And I hope that for those of you that are out there, if there was something that I missed, or maybe you want some more information, you can get a hold of Bob. Bob can get a hold of me, or he can tell you how to find me. I would love to be able to answer your questions or point you in the direction that I think that you can go. I've got friends in high and low places, and
Lee, you can leave comments here, even if you're watching the recorded YouTube version. Leave comments here. I will see those as they come in, and if I can't answer them, I will pass them on. and see if I can get an answer from Tish.
Yeah. Well, thank you so much, guys. I really appreciate it. I'm so sorry that the PowerPoint couldn't work. I mean, I don't know what happened. It worked last night. One of those things.
It is. It is.
But Bob, if you don't mind, I can send that over to you, and you can.
Yes, I sent you an email on how to get it to me.
Okay, fine.
Okay.
All right.
Hopefully it'll work.
So
All right. All right. Thank you very much, everybody. I'm going to let Tisha go there. So thanks very much. Excellent program. Oh, Ted wants to know, does have a question. He asks about aquifers that cross international borders. Do you know of any, especially North America? I would think.
You know what? The Edwards Aquifer there in Texas, it goes down into Mexico, and I know, well, the Oglala doesn't go that far, but if y'all remember the XL pipeline, I mean, it didn't even have to go across international borders in order to, make headline news. But there are aquifers. Remember, aquifers, they know no geographical barriers. They're not going to stop just because it says Texas and we're going to stop right at Mexico. It don't care. It's going. So
yeah, and the water and the pollution and the draining all go.
Yeah, and there is a map that I did have on the PowerPoint, I believe, and it was a map of North America, and it showed all of the major aquifers, and so that would answer his question a lot better than what I could. Otherwise,
that will be in the recorded version that'll be up in the next day or so. I will edit that into the talk.
Okay,
and that'll so Ted, look back for. Ted, look back for that when that'll be, or if you're following us on Facebook or Twitter or Instagram, you should see it when it comes up. One last question. John wants to know if they go under oceans.
Yes, they do.
Great.
They do. Yes, they do. Yeah.
I think there's one. I'm trying to remember. I know there are
places that I think of as like Florida. You have your estuary, and that water's going to go through the sand and all that, and it's going to mix with fresh water and oceanic water. So yeah, that's a great question.
Yeah, it is a great question. I hadn't thought of it. Yes, I know that there are places where there's water, there's fresh water under the sand below an ocean.
Oh yeah, yeah.
But I hadn't thought of that as an aquifer.
Well, now we're going to be thinking about it.
Yeah.
I'm not going to sleep tonight.
All right. Thanks very much, Tish. I'm gonna go solo here and let you do whatever you do. Okay.
Okay. I'm going to go home.
Thank you very much. All right.
Thank you.
Bye-bye.
Bye.
All right. Thank you very much, all of you, for taking your time for the Pinal Geology and Mineral Society or Gem and Mineral Society. Yeah, Gem and Mineral and Gem Society. There we go. Pinal Gem and Mineral Society. And the Pinal Geology and Mineral Museum talk. We will be back on February 17th. Same time, same channel. We do not have a speaker to announce right now. If you would like to be a speaker, please do let us know. You can contact me at Pinal Geology Museum at Gmail. And if you have something to share, whatever you like, if you want to share your collection, if you got pictures, if you don't have pictures, if you want to share whatever your enthusiasm is in rocks, minerals, geology, paleontology, etc., please let me know. And I can help you put together a program if you want to do that. If you are not PowerPoint savvy, if you are not computer savvy, I can certainly help you do that if we get the pictures back and forth. So until next month, or in between on the various things, if you follow us follow us on Twitter, follow us on Facebook, follow us on Instagram, follow us on YouTube. The links all should be in the description of the video. If they're not, they will be shortly. I will double check that. So you can come back in about 20 minutes and you should be able to find them there. I thank you very much. This has been Bob, and we're going to go night night.